Hello and welcome to this super quick Rust tutorial on enigma-3d, a little rendering engine which I wrote and which allows you to display 3D models in real time uh, within an application. So let's quickly look at the feature list. So we have a few features here. I wouldn't call it a game engine at that point because there's too much missing, but we do have an event system. We have an update loop, uh, and we have certain rendering features available. So, um, how would it look? Like this is one of the more advanced examples where we have a bunch of objects and we have post-processing and UI and everything more or less. Here we see the example of a geometry shader which renders all of these individual grass blades as well with post-processing UI, etc. Here we see actually the full power of instancing which we have available. So cloned objects will automatically be handled as instant draw calls. And we have like transparent objects and opaque objects. And here just a little post-process thingy. This is actually a very little game I did. It's basically Flappy Bird. It also tests like our collision system. Currently we only have box colliders. Or who's we? I. And here we see like some code on how a function, how a little application uh, could look like. So let's actually see what do you need. Very first thing is obviously to add enigma-3d to your project with the package manager, and then you need to compile the project um, because there's a lot of dependencies which need to be loaded and compiled, and this is just here a very basic project. So how can we now get our Enigma window? Our Enigma window is constrained out of three things. We first need an app state, we do need an event loop, and we need a camera. So all three of these we create. So let's do let app state equals app state. Here we have it. We'll just say a new one. We also need an event loop. Event loop new. And this event loop requires a window title and a resolution. So the resolution is obviously adaptive, so you can rescale your window, but this is basically the resolution the window will open with. So let's say presentation window, and the width we set to 1080 and the height to 720. So this is like a HD window, not full HD. And the last thing we want to have is a camera. So we say let camera equals camera, and there should be a default. So we don't, this default camera will just spawn on the vault origin. If you want to move it, you can afterwards go in there, camera.transform.position, and give it any position you want for it. So you could now move it to 0, 0, maybe move it up a little bit and move it back a little bit, so 2 meters back. It will probably, when we now compile, yeah, it will actually say this is set position, not position, and now it will actually complain that this is not mutable. It also tells you that there currently unused variables, obviously. So the first thing we now need to do is we need to add the camera to our app state. So we say set camera, and we set the camera. Same here, we need to make it mutable. So we add this mute here, and then we run our event loop dot run. And there we add our app state in as an arc mutex. We put it in as an arc mutex because we want to have it in our render loop and make sure everything is threaded correctly. So now if we run the application, we open up a simple window which looks like that. We don't have any controls or nothing, but you see we already have a skybox available. The very next thing we now want to do is we want to add some default controls. We can do this with the init default and pass in a mutable reference of our app state here. What this will do is it will create some default behavior. So now what we have here is we have now a camera controller. You can move the camera around. And we also have a selection system. Obviously, we don't have anything in the scene right now to select, but if we had, you could see that we could select that. Speaking of nothing in the scene right now, I think the very cool thing we can now do is we can add some objects, right? So let's create a little folder called resources. So you can call it whatever you like, obviously, but resources is a good name. And in here, we should put in maybe an object, right? So let's put in simple Suzanne mesh. This is a GLB file. And we also want to maybe have a texture. So let's look at some texture which we could apply to this. Maybe a UV checker texture. And last but not least, I'm not happy with the default skybox. So let's actually copy in another skybox, which we have here, which is skybox experiment. So let's first say with all of these resources available, how do those need to be prepared for proper implementation into our application. So first we could obviously just use the full path to load those things, but the problem is the path is not like a reliable source when we build the application and want to share it, right? So in this case, we actually built some little functions. For example, skybox texture, and these functions return a static reference of a U8 array. Why a U8 array, you ask, or you don't? But yeah, this is actually just like a byte array. So, and here we can use the include bytes macro with the path of that actual object. So we are here in main, so we can just say source slash resources slash skybox experiment dot png. So this is now our new skybox, and we can set this skybox before we start the loop. Let's make a few comments so we see what we are doing. Create camera, set skybox We first want to create a texture out of this. So we say skybox texture equals a new texture from resource. And why from resource? Because we basically created a resource function here, right? We load it into bytes. We want to have a display reference of our application. For this, we can always reference our event loop dot get display reference. And then we want to have our skybox texture function, which returns our texture array. And we can then use the app state to set skybox from texture, pass in the skybox text, and also a reference of our event loop. And that should be it. So now, if we run the application again, what is the issue? Apply fix. Yeah, we shouldn't have the source here. Okay. So now it finds the different skybox, which is a little bit more grounded and not just air. So let's actually make more of these here. Two more to be precise, one being UV checker, which is the UV checker PNG. And this is the Susan, GLB. Okay, these are our, let's add a comment here, resources. And here we can now say, okay, what do we want to do with those? Let's add an object. Add Susan. So the very first thing we want to do is we want to add Susan as an object. So we say object load from GLTF resource because we have a resource again, right? So we say Susan here as our resource, and we have a Rix multiplier. We don't care about a Rix. This thing doesn't have a Rix, so we can just pass in none here. This object needs obviously a material, otherwise it will crash. So let's also create a material for this. Material, say material, and we just go with a PBR material at that point. Again, we need a display. We can get this again from the event loop. This time we want a clone of it. And this is not a transparent material, so we can set it to false here. Yeah, we can now actually add the material to Susan. So Susan dot add material, Susan material, and we want to use the UUID of this material. Again, we need to have it mutable. And when we have this in place, we can just say, okay, now let's add everything we have to our app state. App state dot add material, Susan material, and also app state dot add object, Susan. Now, if we run that whole thing, we see the black Susan object here. And if we select that, you see we get actually message events that the selection works. And also we now create this little logs folder here, which automatically tracks our whole log. This is something which Enigma does for you. Enigma has its own logging system, so you can use it for custom locks, but also just use the already implemented locks. Let's now give the scene some light. How do we do this? Add lights. So the very first thing we want to have again is a light. Let's call this sun. And there we say create a light. A new one with a position of maybe 3, 5, and 3. Then we want to have a color. The color we make it white. So we say 1.0. Intensity wise, we just set it to 100 for now. It might be way too bright. Direction, this will be a point light, so we don't give it any direction. And shadow casting is currently not implemented. It will come at some point when I get to it, but for now we just have to set this to false. If you set it to true, that's also not a biggie, but it will not do anything. And then let's add that sun to our app state, right? App state dot add light sun, and it wants to know what light type this is. So we say light emission type dot source. It's not an ambient light; it's a light which has a source. And now if we hit this, we have a wonderful lit object here. Let's maybe also add an ambient light to show you that this also works. For that, I just copy that here, paste it there, but make it way smaller, maybe 0.3 in terms of intensity. The position doesn't matter for ambient lights because ambient lights are just applied in everywhere, right? That's why they are ambient. Add light, and then we say ambient, and in this case we do ambient as an emission type. And also, let's maybe do this maybe a little bit reddish. So now you see we have a reddish ambient light and a white main light. I'm actually not a big fan of that reddish ambient light. Let's make it white again. Sorry for that one. It's also way too bright, so let's set it to 1.5. And let's maybe set the color a little bit in the sun. Make it a little bit yellow or bluish. See, this looks a little bit better in terms of lighting. You also see we currently have very glossy reflections. But very first we want to add a texture to our material. So let's go back to Cezanne and to the Cezanne material, make this also mutable and say Cezanne material dot first let's create the texture. Let UV checker text equals a new texture from resource, right? We have this up here already. We pass in the event loop.getDisplay reference, and instead of the skybox texture, we now say, okay, we want the UV checker. This will also get rid of this annoying warning we have down there of dead code, because we now use this function. There's the sand material then, dot set albedo. There we just need to set the albedo texture, which is the UV checker texture. And now, if we run that whole thing, we suddenly have a texture on our object. And that is it. Let's quickly see how we can implement maybe a little bit of post-processing as well. That will be down here. Post-processing. So for here, we actually just go with, I don't know, let's do a little bloom. So we say appstate dot add post process, and here we want to have a new box. And we say, okay, we want to have a new bloom, maybe. This needs a new display clone, so we say event loop dot get display clone. Actually, a display reference only. Yep, that's the way. We want to give it a threshold when the bloom should kick. So we say 0.999 because it should really just get the very first things, and we set iterations. The very highlighted things. We set 15 iterations for now. That should be it. And now we should have a little bloom in there. Bam. Okay, it's pretty bright. But you also see like how it interacts with the object. And it actually bleeds a little bit in the object. We do have different ones. The lens dirt is actually quite nice as well. Let me quickly introduce this to you as well. Lens dirt. Again, you want the event loop that display reference. And this actually takes a texture. So we can actually now say resources lens dirt texture. This is like a special resource which comes in with the engine as well. Give it an intensity. Let's just say C.0 for now. A tile scale, which basically makes that whole thing tile. 800. And how sensitive it is to light. So let's also add that here. And now we also have a little lens dirt available here. You see it here, especially close to the bloom, it appears. Yeah, so far for the very first introduction to how to build a little scene with enigma-3d. You can't do much with that scene now, but in the next tutorial I will actually showcase you how we can make a little UI and maybe also some event functionality or update functionality. Have a nice one. Cheers.